in baseball, in a baseball playoff series, the two teams are evenly matched. The two teams must play until one team wins 3 games, and no ties are possible. Use the rows of random numbers shown to approximate the probability that the series will end in exactly 4 games. What is the maximum number of games that could be played? So let's start with that question. So two teams are playing games against each other, 2 baseball teams. And the 2 teams must play until one team wins 3 games. That's what it takes. So maybe, Team A wins, and then Team B wins, and then Team A wins again, and Team A wins the 4th game, and it's over, right? That'd be an example. That'd mean Team A wins. The whole series took 4 games, and Team A won because they won a 3rd game. Or let's say maybe Team B won, Team B won again, then Team A won, then Team A won. Now they got to play a 5th game because it's tied 2-2, and maybe Team B wins. So that's 5 games. So that's the most it could take, right? 5 games is the most it could go because they could be tied 2 games, and then somebody wins the 5th game, which gives them 3 games total. Remember, they play until one team wins 3 games. So the most it could do, the maximum number of games that could be played is 5 games, isn't it? What's the least? What's the quickest it could happen? 3 games. If B, for example, or A wins 3 games in a row, either way, then it's over, right? Because it's the first team to win 3 games. So they could just win 3 in a row and it's over. Or it could take 4 games, or it could take 5 games. That's the most, though, because it's a 2-2 tie after 4 games, and then the 5th game decides it. So it's going to take 3, 4, or 5 games to get somebody to win 3 games and end the series. So now let's come on down here. Use the rows of random numbers to approximate the probability that the series will end in exactly 4 games. So we want to know, what's the chance of the series only taking 4 games? Doesn't matter who wins, one team or the other, but what's the chance if the 2 teams are these are evenly matched, they're even Steven, they both have a 50-50 chance of winning a game. They're even Steven. What's the chance that the series will end in exactly 4 games? The probability that the series will end in exactly 4 games. So we're going to use these digits over here, this digit table, to simulate this situation. How's it going to work? Well, it says let the even numbers represent a win for A. So A wins with 0, 2, 4, 6, or 8. It's a win for A. And odd numbers represent B. So B wins if you get a number 1, 3, 5, 7, or 9. So that's even, right? Because they both have 5 digits, same amount of digits, even, Steven. And they're saying 0 is an even number. We know that. All right, so now let's come over here and we'll let this first row up here, we'll let this first row be 5 games of a series. So the 7, let's just mark them as we go here. So the 7 means who wins? Odd is B. So B wins, and B wins, and A wins, because that was even, and A wins, because that is even, and so they're tied 2 games to 2 games, so they have to go to the 5th game, and it's odd. B wins. That's funny. That's this exact situation I wrote here. So that first series took 5 games. The first series took 5 games on that. So so let's keep going. They want us to go all the way down, so let's do the next series. So the next series is going to be a 2, that's A even, A, and then odd is B, A even, B odd. Again, it's tied 2-2. And the 5th game is is even, it's A. A wins. Again, it took 5 games. Because it was tied, after 4 games, it was tied 2-2. So, we got to keep going here. Let's try the next one. So that was the first series, took 5 games. The second series took 5 games. The third series, A is a 0 is A, so even A, and this is B because it's odd. A for even, B for odd. Again, they're tied 2 games to 2 games. The last one is even, so that's A, and that took 5 games again, because they were tied 2-2 after 4 games. Okay, let's go to the next one. Odd is, I keep forgetting, odd is B. Odd is B. This is A because it's even. And this is even. And odd is B. They're tied 2 games, 2 games. The last one is even. That's A. So again, it took 5. All these are taking 5 games. Next one. Odd. 3 is odd, so that's B. Next one is odd. That's B. Next one's even. A. 7 is odd. B. Oh, boom. There we go. That one only took 4 games. See how it's over? We don't even need to do that 0. We don't do that last one. That series only took 4 games to decide a winner, right? It's the first one to win 3 games. Well, B, it was B, B, then A1, then B, and it's over. I don't even need to do the 5th game. B won 3 games to 1. That series ended in 4 games, which is what we're looking for. They're trying to see if it'll end in 4 games. So far it's happened 1 time out of the 5 different times we've simulated the series. Let's keep going. So 2 is A even, 8 is A even, 3 is B odd, 6 is A even. It's over. Again, there it is, 4 games. A won 3, B won 1. It's over in 4 games. There's another time it happened in only 4 games. Now it's happening a little bit. Next one, 9, that's odd, that's B. 7 is odd, B. 4 is A even, 2 is A even. It's tied 2 games, 2 games, got to go to the 5th game. The 3 is odd, B wins. That took 5 games because they were tied 2 games to 2 games. Had to go 5 games to decide it. Next one, the 8 is even, that's A. 6 is A, 2 is A. There it is, look, 3 games in a row. A, it's over. The series only took 3 games. A won 3 in a row, and that ended it in only 3 games because A won 3 in a row, even. So that was a 3-game series. And next, odd B, even A, odd B. So it's tied 2 games to 2 games. They got to do the 5th game. B wins it. It took 5 games to do that. One more. Odd, 1 odd B, even A, odd B. Boom, over. There it is. That was decided in only 4 games because B's already won it 3 games to 1. So that was another 4-game series. So how many total times did we do this? There's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times we did this series. 10 different times. And among those, 1, 2, 3 times it ended in 4 games. So it ended in 4 games 3 out of 10 times. The series ended in 4 games. Divide that, it's 0.3. So the probability, we just simulated the probability that the series would end in exactly 4 games. It happened 3 out of 10 times, 0.3. So that's how we use a simulation, random digit table, to simulate the question. If 2 teams are evenly matched and they're going to play a first to win 3 series, what's the chance, what's the probability that it'll end in exactly 4 games? Well, we just did it. We just simulated it, and it came out 3 out of 10 times. Seems like there's about a 0.3 or 30% probability the series will end in 4 games exactly.